Hi everyone, good morning. Myself Dr. T. Jagdish, working as Assistant Professor 3 in the Department of Electronics and Communication Engineering, KPR Institute of Engineering and Technology. So now we are going to see an interesting topic in control system, stability analysis. Stability analysis. So as we know, for a linear time invariant system is concerned, we can say when a system is said to be stable. So as far as your input is bounded, I should get bounded output. What is the meaning of bounded? I should give some finite value as an input and I should get finite output. If that is the case, then a system is said to be stable. So this is the essential criteria for a system is said to be stable. There is one more criteria to check the stability of the system. So if there is no input signal, my output should be 0. If this condition is satisfied, then a system is said to be stable. So these are the essential criteria for a linear time invariant system is said to be stable. Now, we will take in S-plane, let us take real axis and imaginary axis. If the poles of the transfer function, lies on the left half of the S-plane. The poles lies on the left half. That means my left half of the S-plane is this. If the pole lies here, then the system is said to be stable system. If all my poles lies on the left half of the S-plane, then the system is said to be stable. If the pole lies on the right half or on the imaginary axis, then the system is said to be unstable system. So this thing you should remember while checking stability in control system. Now we have a criteria called Routh Hurwitz criteria, which was proposed by Professor Routh, to check the stability of a system. Based on his criteria, how to check the stability of the system? So to check the stability of the system, we need to construct Routh array. So you know array, it is a combination of rows and columns. So for the given characteristic equation, we should construct Routh array, and if there is no sign change, in first column of the Routh, then we can say the system is stable. So this is the main criteria proposed by Professor Routh. So how to check a stability of the system based on his criteria is we have to construct Routh array, and there should not be any sign change in the first column of the Routh array. And one more point adding to this is the number of sign change, the number of sign change tells the number of roots lie on right half of the S-plane. So this is one more point which is added to this criteria. If there are multiple sign change, if there are two sign change, then we can say two roots lie on the right half of the S-plane. If there are three sign change, then we can say three roots lie on the right half of the S-plane. So now I'll explain you how to construct this Routh array table. So for this, let us take a polynomial equation f of s, which is equal to a polynomial equation f of s is equal to, let us take a naught s power 5 plus a1 s power 4 plus a2 s cube plus a3 s square plus a4 s plus a5. Let us take a polynomial characteristic equation. Now for this we are going to construct Routh array. So how to construct Routh array is, so first we will draw a table. Now we have to arrange this according to the power of s in descending order. So we have highest power is s power 5, then s power 4, s cube, s square, s power 1, s power 0. So according to the highest power of s in descending order, you rearrange this in terms of s. Then we have to see the highest power of s value. So you have to see the highest power of s value. So it is an odd number. So you know 5 is an odd number. So first you should fill odd power of s coefficients here. So I should fill odd power of s coefficients. Then I should fill even power of s coefficients. Then I should fill even power of s coefficient. Suppose if the highest power of s is even, first you should fill even power of s followed by odd power of s. So in this case my highest power of s is odd, so I need to fill odd power of s coefficients. Then I need to fill even power of s coefficients. So my odd power of s coefficient is a0, a2, then a4. So I have 3 coefficients, that means I will get 3 columns. So don't put the columns first. According to the number of coefficient, you should put the columns. So I have 3 coefficients in odd power of s, so I should fill 3 columns. Then you fill the even power of s coefficient. So even power I have a1, a3. Include your constant as even power. Always include your constant. A power 5 is constant here, so include that in even power. So this is my preliminary step in my Routh array. First, we have to look at the highest power of s. If it is odd, fill odd power of s coefficients, then even. Suppose if it is even, fill even power of s coefficients followed by odd. Then the remaining columns I will tell you. So first I will put b1, b2, b3, c1, c2, c3, d1, d2, d3, e1, e2, e3. Now I will tell you how to calculate this b1. My b1 is a1, a2 minus a0, a3 divided by a1. This is my b1. That means a1 into a2 minus a3 into a0 divided by the immediate first coefficient above the row, that is a1, that is b1. Next, what is b2 is a1 a4 minus a0 a5 divided by a1. So that means what? You should keep the first column constant and move the remaining columns, cross multiply, subtract. This is the general procedure. So I should keep the first column values constant and I should keep on cross multiplying with the successive columns and subtract it and divide it by the first element of the above row. So this is the general procedure. So A1 into A4 minus A0 into A5 divided by A1 gives you B2. Next B3 is A1 into the next coefficient after A4. So here after A4 there is nothing. So B3 will be 0. Next I will explain you how to find C1. So my C1 is, now we have calculated this row B1, B2, B3 row. Now I want to calculate C1. So what we have to do is, we have to consider the immediate next two rows of C1. So here I have to consider S3 and S power 4 row. So for which row you are going to calculate, the immediate above two rows we have to consider. So here I am going to calculate for S square row. So I have to consider S3 and S4 rows alone. So my C1 is, so how to find C1 is, so my C1 will be B1 A3 minus A1 B2 divided by B1. So B1 A3 minus A1 B2 divided by B1, that gives you C1. Similarly, my C2 will be B1 A5 minus B3 A1 divided by B, that gives you C2. Clear? B1 A5 minus A1 B3 divided by B1, that gives you C1. Likewise, we have to find for the remaining two rows. So this is how we need to construct this Routh array. Once you construct this, you have to look at the sign of the first column. So you have to look at the sign of the first column. So my first column is, so what I have in the first column? So my first column, so in my first column I have A0, A1, B1, C1, D1, U. So this is my first column. So this coefficient should be positive. If all these coefficients are positive, then the system is said to be stable. Clear? This is my Routh-Hurwitz criteria statement. If you look at here, if there is no sign change in the first column of the Routh array, the system is stable. So what is my first column of the Routh array? A0, A1, B1, C1, D1, E1. If all the coefficients of this column are positive, then the system is stable. So this is all about Routh-Hurwitz criteria. So I hope I am clear with what is stability and what is Routh-Hurwitz criteria, how to find Routh array. Thank you.